although I can't see the audience, but that is fine.
Thank
you.
So, just a brief introduction about Professor Alok Dhawan, and he asked me just to be very brief in his introduction. So, I will say just two things about Alok. That very recently there was this NAC accreditation of Lucknow University, and there was a wall of fame of all the departments, science, arts, commerce, education, law. He is one of the very few persons who exist in the wall of fame of two departments, chemistry and biochemistry. Chemistry is that is very unique of him. बड़ी लड़ाई झगड़ा हुआ कि हमारा नाम नहीं है, इनका नाम दो जगह है। तो ये इससे ज़्यादा मैं क्या कह सकता हूँ इनके बारे में? A++ grade भी मिली. He was earlier the director of IITR, Indian Institute of Toxicology Research. Earlier it was ITRC, Industrial Toxicology Research Center. मैंने PhD वहीं से की है, और अभी ये CBMR के डायरेक्टर है. पीछे लिखा हुआ है देखिए इनके CBMR Center for Biomedical Research SGPGI कैंपस में है. तो इन्होंने कहा था मेरे बारे में कम बोलना, तो इतना ही बोलना काफी है जो है. Very distinguished person. बाकी ये खुद ही बोलेंगे.
Thank you so much, Sudhi. Thank you. I really appreciate. और मैं अपने गुरुजनों को सामने बैठा देखता हूँ. प्रणाम. प्रोफेसर द्विवेदी जी है, राजेश प्रसाद जी बैठे हैं. नमस्कार सर. और मैं पहले तो माफी मांगता हूँ ऑर्गेनाइजर से कि मैं प्रत्यक्ष रूप से वहाँ पर कुछ ऐसी आगे के दोस्तों कंट्रोल के बाहर थी तो ऐसे में दोस्तों. लेकिन मोना जी मेरा प्रॉमिस था कि हम जरूर ट्राई माय बेस्ट. तो अगर आपको भी इजाजत हो तो मैं स्क्रीन शेयर कर सकता हूँ.
बिल्कुल प्लीज.
जरा मेरे को परमिशन दे दें स्क्रीन शेयर करने की.
स्क्रीन शेयर वहाँ से लैपटॉप से
वहाँ से पार्टिसिपेट करके करिए. Multiple.
If the organizers can hear me, please give me the permission to share the screen.
मेरे ख्याल से आप कर दिया इन्होंने.
Now check.
Yeah, now it is fine.
हाँ.
Yes.
So, are the slide visible now?
Yeah. हाँ, slide is
Should we can confirm?
हाँ, slide is visible. Please move ahead.
Okay, thank you. So, I think let me first congratulate Dr. Mona Saxena for organizing this wonderful meeting and trying to see from wherever she could get the speakers, not only from India but also from the US. And I must say it is my, I'm losing out on not being there in person. Currently, I am conducting research as today mentioned to you, it is an autonomous center of the government of UP. And I can be discussing with you what we do at this center and participate that it is only one of its country in the world of this kind of centers are available. So I would also urge that the researchers or the medical students who wish to come and visit us, they are most welcome. So I'll be talking about how we are basically looking at the disease conditions and how we are helping to find out new diagnostics. So this was set up as a project of the Department of Science and Technology, Government of India at SGPGI. And that time it was a center of biomedical magnetic resonance. So basically it was an NMR-based center. And we were looking at that point in time about the metabolomics in patients. And that was very unique at 22 years ago almost. And later on, it became approved as an autonomous center in 2005-06. And then we kept moving on, and we also got 3D functional MRI, 3 Tesla functional MRI. So we could also look at the cognitive functions in humans directly and see what will happen. And then later on, in 2013, we became the Center of Biomedical Research to expand our horizon. And we also have now added some very distinguished chemists in our institute. As you can see, the vision is to undertake, promote, develop, guide, and coordinate basic clinical and translational research, which will be also the kind of thing that we are discussing today in this meeting, and the mission of this CBMR is to establish an enabling ecosystem for cutting-edge interdisciplinary research. And now we have added that we also would like to see if we can come up with entrepreneurship for better patient care. So all our work that we do is towards clinical diagnosis or towards clinical betterment of the patient. So just to give you a sense of how we are as an institution, so Nature Index ranks the institution across the world. So if you look in 2020 to 2021, among government sectors, in India we are among top 10. In Asia Pacific we rank 46 and globally we rank 128. And if you look at chemistry, we are number 4 in India and number 49 in the world. So that would give you a sense of the quality of science that happens at center of population. And this also gives you a sense of the quality and the quantity of work that we have done so far using clinical metabolomics. We have already done about 25,000 patient samples in NMR of almost 48 to 49 divisions. And we've done almost 4,000 patient samples in MRI. Which has essentially the portfolio of CBMR currently that we do basic, applied and translation research, both in chemistry and in biology, and at the interface of chemistry and biology. And as you would see that the 3 units that we made were molecular diagnostics and genome research unit, which is there, a molecular synthesis and drug discovery unit, and a translation cell biology. And as we move forward, it went ahead into departments. We have now constituted Department of Data Science because a lot of data is not coming in from the medical field, so we need to make sense out of it. This data should be converted into devices, so we now have a Department of Biomedical Engineering and Devices. We have a Department of Advanced Spectroscopy and Imaging, a Department of Biological and Synthetic Chemistry, a Department of Systems Biology, and of course an incubation center. So just to give you a sense, and this, when I said it was very unique, so if you look at the NMRs that we have a 600 megahertz solid state NMR, which is the only one of its kind in the country. We have a 800 megahertz solution state NMR used in clinical metabolomy, again the only one in the country. And we have a 400 megahertz NMR, which is used for chemistry and other purposes. And we have a 3 Tesla functional MRI, again a very unique machine where we can look at various aspects of the brain. If I look at just the past 5 years, we've done almost several thousand samples in terms of diagnostics in collaboration with SGPGI, but we've also done more than 1,000 samples for translational research. And when I say translational research, we are looking at the disorders, attention disorder, bipolar, obsessive compulsive disorder, depression, Alzheimer's, deafness, dementia, etc. To look at the neuronal sort of mapping, trying to make artificial intelligence-based models, and then trying to figure out if we can help the patients at an early stage. And some of the examples I'll share. So if you look at this example of the translation research looking functional MRI, so the PGI in Lucknow actually carries out cochlear implants, and the failure rate is also there. So what we are doing is trying to look at the neuronal connections and the plasticity of the brain, and ultimately we were able to come up with a model where we could predict prior to the operation whether this will succeed or not. And so therefore, just in 1 year, last year, we got 22 patients referred to us where there was a doubt in the mind of clinician. And out of that, we said that 18 patients would be fine to do this implant, and all the 18 patients were 100% successful. So here we have converted whatever research we did, also published in very high-end journals, as you can see, into now something which can be used for the patient directly, and now we are expanding this to all the machines which have 3 Tesla and UP, and we'll be saying them free of cost. The second example I would share with you is that of ADHD. I thought I'll just give you a couple of examples, one from PGI, one from KGMU. Generally, the child is discovered as ADHD between 6 years, 7 years, and the sort of upper limit to where it can be rectified is around 12 years. So you have a window about 3 to 4 years in which the child has to be trained, and the parents have to sort of learn how to live with that child. But here what we will do that over a period of time through scanning the children, we will now figure out the AI model which can identify a child whether the child is going to become ADHD as early as the age of 3 years. And this is allowing the clinicians as well as the parents and the child to give them a window of almost 8 to 9 years, and by that time the child would have recovered fully and would be able to adapt to this. So again, through this model we were able to provide our bit of information that we gathered for almost 13 patients last year, which were referred to us from HCM. So this is a direct research translation that you can see again, brain development, brain engineering behavior, very good papers, and now we are publishing more papers in this area. But this has been translated immediately into diagnosis of disease at an early stage, and also follow-up can be done. This was another sort of study done using functional MRI, where we looked at extensive long-term verbal memory training associated with their brain plasticity. And here we looked at scholars who were chanting Vedic mantras. And we were able to show that when they are chanting Vedic mantras versus people who know Sanskrit but they don't chant it in the way the priests do, we found that the priest memory was very strong, and so therefore it was very useful that very scholars for brain fitness and clarification in insular supplementary motor areas, frontal brain areas, regions, and caudate and temporal core. So this has now opened up a whole new area. We are now working with different kind of people in terms of memory and how the memory can be enhanced. Similarly, if you look at the NMR-based metabolomics that we are doing, as I mentioned to you, we have very powerful NMR machines, and we are able to look at disease metabotyping, which essentially means that we are able to figure out the disease conditions at a very early stage and also differentiate between the disease conditions. And finally, also look at therapeutic outcome, and also look at how we can convert this into a diagnostic. Because if you consider a PHC, the patient is first referred from PHC perhaps to a district hospital, from there it comes to maybe a bigger hospital, then they come to PGI, and then from the patients who come to PGI, some of them are sent to CBMR, or the samples are sent to CBMR to look at the metabolomics of these patients. So if we are able to convert this into a device, that device can actually be taken all the way up to primary health centers, and the diagnosis can be made at that point in time. This is where we are headed to. So that is the new area that we are getting into now. So as you are aware that there are different kind of omics that you are seeing here are not related to those tumors, the gene, RNA, protein, and the metabolite. So this is like a sink. If you take the serum or blood or any of the circulating fluid molecules, it's not metabolites in this. So how do you make sense of this question? So then you basically look at the metabolites. You have to look at the study time, the choice of products depending on the disease that you're studying, and then the kind of NMR acquisition that you do. And ultimately, we look at the spectrum and data processing, and then we look at the statistical analysis. And finally, we have to do the biomarker validation. So currently, we are at the biomarker validation stage. Some of the places you will find that the data is hidden because it is either under patent or it is under development for device. So here you will find that our metabolomics we can do both at preclinical stage as well as clinical metabolomics, and both of them are being conducted in our institute. So for example, if you look at autoimmune inflammatory diseases, there are so many diseases and some of them have been worked out in our institute. Especially if I look at pulmonary sarcoidosis versus pulmonary tuberculosis, is a good example that we studied, as well as in the case of spondyloarthritis. Also in the case of Takayasu arthritis, all these cases we have been able to identify a set of markers which get up or down regulated, and based on that we are able to identify the patient and inform the clinician as to the disease which the patient is suffering. And these are only cases where the doctor is not being able to make a clear-cut diagnosis. So essentially what happens, we take the samples from there, we put them into the NMR machine, and the major advantage here is that we don't have to process samples per se if you're taking liquids. And then you look at different disease conditions, or you look at whatever you want to, and this part on the right is hidden because of the fact that the markers were shown here. But I will just share with you that once you are, for example, in sarcoidosis, the sarcoidosis and tuberculosis patients present clinically almost the same. But when they are given anti-tubercular treatment and they don't respond, then that is where the doctors feel that the patient must make the sarcoid patient. So what we are able to do is to identify very clearly between the sarcoid and the TB patient. And because of which now we get a lot of patients from SGPGI where we are able to differentiate between the two. And currently, rather than do a culture, we can actually do NMR. It takes about an hour or so. And within the hour, we are able to inform them. So now, because we are able to identify these biomarkers, or a set of biomarkers, or a molecular signature of biomarkers between sarcoidosis and tuberculosis, we are now tied up with IIT Bombay, and we are converting this into a device. So as I mentioned to you earlier, we have now opened a department of biomedical engineering as well. So what we are trying to do is convert all these different kinds of biomarkers into devices so that it can be used. So the process is that once the device is made, we definitely do some internal validation, but then it has to be sent through ICMR so that various multi-centric trials can be done and seeing whether this device is going to work or not. So currently we are working on 2 devices, which we hope to finish off by middle of next year, and then the validation exercise will happen. So as I mentioned, one, we are doing the differentiation between sarcoid and tuberculosis. And this is very important for us. And the other one that we are working on is on ARDS. So here are some of the panel of the different metabolites which have been shown to be very sensitive and specific in case of sarcoid versus tuberculosis. And so we are able to differentiate very clearly depending on the amount of these metabolites that are present in the serum. So our aim is to either develop sort of lateral flow device or a small electric device, digital device that can capture the information and send it to an app on the mobile phone. Same with autoimmune diseases, as I mentioned to you, that we have been able to work with the autoimmune disease and been able to identify markers. The complications are also there, and we are continuously increasing the number of patient samples so that more validated results can be gotten when we get into the development of devices. So this again is the case of Takayasu arthritis, where we were able to identify the different markers that are getting upregulated or downregulated, and as a bunch of these markers, we are able to then identify the disease. So these are all papers that have been published by our institute. And glutamine seems to be a major marker that is now coming up in the good. And so again, in this case, the device is already processed. coagulation pump, which is ARDS. Again, something that was very common if you look at the COVID scenario where people were getting lung infections and people died. So one thing that our scientists were able to do is look at, in collaboration with the critical care medicine department of SGPGI, look at how the patients come to the ward, either mild, moderate, or severe, as per the scores, Apache and SOPA scores of the pulmonary medicine department, and then try to see the metabolites using either valves or mini valve or the serum, and then see as to how it progresses. I think we were able to share with the clinician that whether this person who has come in as a mild case will get into severity within 2 to 3 days time, and this has greatly helped the clinicians from PGI to be able to monitor the patients and also to be able to manage them in a better way. So if you look at the different metabolites that we are able to identify, so these are the mild, moderate, and severe, and these are the diagnostic criteria that we have. These are the volume definition, and these are the different etiologies to which ARDS happens. So this was again a disease we thought was of immense importance, and also in discussion with PGI, we thought this would be a good idea to take forward as a device. So for ARDS also the device was in process. We were able to identify the metabolites which we have now shared with IIT Mumbai, IIT Bombay, and currently the device is under the process of development. And so as I mentioned to you, the clinical score is using either Apache or SOPA score. But when we looked at our score, we found that both in the bronchoalveolar lavage fluid, which was valve, or the serum, the fluids that we could collect and do NMR were very similar. So we have quite a good number of patients, and currently we are also in discussion with IIT Kanpur, and we have already signed with them to look at this kind of data and see if they can develop an artificial intelligence model based on this data. And as you see, this is for the mini valve, and this was the serum, and you find that almost all the markers that are visible are there in both these groups, both in the valve as well as for the serum. So we are able to identify these and use this as a sort of diagnostic markers for them. And also we are able to inform the clinician as to whether this patient, as I mentioned to you, would be getting into a severe mode sooner than later. So these are some of the markers that we are able to identify. And if you look at the correlation between the markers and the Apache score or the SOPA score, it is pretty high, which shows that our markers are actually not only coming up early but are also in consonance with the clinical markers. So as I mentioned to you, both the serum and mini valve can be used, and currently this is what we are doing, and we are headed into, we are also increasing the number of sample size in our institute, but as soon as the device is ready, we will be heading into diagnostics as well as therapeutic outcomes of the treatment, and we monitor these kind of devices. So as I mentioned, this has come up in a very big way, and we are very excited, and so are people from SGPGI, that we are able to identify some of the biomarkers in the field. Also, a couple of papers that we recently published, I thought I'll just show you that a lot of basic work goes on, but again, related to essentially what happens in the patient. So here is the case where one of our faculty members, we've been working with G14 beta-5 complexes, and we've been able to figure out that these complexes actually drive the acetaminophen induced hepatotoxicity. And this was published in 2021 at Diagnostics with impact factor, which is 11.8. Very high-end, I would say, basic science that is happening. But again, if you look at this in human liver, you've been able to get liver biopsies on which you've been able to do this kind of work. And similar case was the hepatic RGS6 ATM complex which drives the NAFLD, and this also got published in Draft's Biology in 2021. So what I'm trying to just give you, and this again both human samples as well as in the in vitro that you've been able to say with great degree of certainty that these are the switches that happen when the disease progresses. So I think this, in a sense, gives you in a nutshell what our institute has been doing and the kind of interdisciplinary work that we do, which results not only in the advantage of the patient, but also in the long run, perhaps in a couple of years, we'll be privileged to some of the devices that are going to come out. We have now opened our institute in terms of usage of the machines by others. The permissions have now been granted by our government council. So I'm very glad that whoever wishes to use these machines are welcome to do so. In case there are clinical samples, we will be more than happy to see how we can collaborate together. If there's some fundamental science that needs to be done, that also can be looked into. I think with this, I would again thank very profusely Dr. Mona for inviting me to give this talk, but also would at the same breath, in the same breath, would also like to apologize for not being there in person. And I've promised Mona that I will definitely come in person to the department, where I'll be happy to interact with the students and see how I can motivate them and perhaps do some collaborative work with our institute. So thank you very much indeed for your time, and thanks once again for organizing this online. Thank you very much. Thank you.
So big round of applause for Professor Alok Dhawan. He gave an insight into the mandate of the institute which he is heading, and the good thing is that whatever they are doing is for the benefit of the society, for the benefit of human beings, for the benefit of patients, and the latest state-of-the-art machines are there. I have been there in person. I have seen all those machines along with MSc Biochemistry, Biotechnology, 4th semester students.
I can't hear you.
Achha, you can't hear me, jo hai. Can you hear me now?
देखो बेटे क्या है
इसमें आवाज लैपटॉप पे बोल दीजिए
लैपटॉप पे बोल दीजिए
हाँ आवाज आ रही है मेरी आलोक हाँ तो मैं थोड़ा सा आपकी इशारे में थोड़ी सी बातें कह रहा था जो है तो पब्लिक ने सुन ली जो है और so you want to ask a question?
Yes.
Okay.
Can I give you my
हाँ sure. You can come in. There is a question Alok for you.
I'm Dr. Suman Kumar Mishra. I'm an endocrinologist from Lucknow, USA. I want to ask you about ADHD. Did you?
Sir, not your voice, sir.
So you can come in front of the camera.
Not your voice, I can't hear you.
Yes.
Can you tell me some more about the functional changes in the functional MRI?
I can't hear you, sir.
Can you hear me?
Yes, please.
Camera. So please the camera.
My question is, what are the functional changes seen in ADHD in a functional MRI? Number two, I was going to follow your lecture with a talk here. I'm going to see the functional MRI's role in diagnosis of the site of action of SGLT2 blockers in the hypothalamus. So I'm glad that you're talking about the functional MRI here, but I'm curious about the ADHD. What is the change in the ADHD in the functional MRI?
The two cases that I described to you, one was in the case of cochlear implants, where we were able to clearly differentiate the intervals that actually go to the
I cannot make out what you're saying. That's okay.
hello. Can you hear me now?
देखो
I
भैया
can hear you.
Can you hear me? Okay. So the two things that we are able to do, one with ADLG, we are able to identify the activities in the different areas of the brain. I am not able to tell you the exact functions right now. That AI model is currently under patent. And the second, in the case of the intracochlear transplant or implant that we are looking again, we are able to find that the neuronal bundles that are actually responsible for hearing, they actually do not get to the point where you can hear and they are aligned to other places. So if you are able to differentiate between the two, in the control, you can actually find a very good connection between the bundles so that you can actually hear. But in the case where the bundles have been attached differently, the person is able to do other jobs very good, but in the case of hearing impairment will not get resolved. So based on that AI model, we are able to predict that, and this has been 100% successful as far as PGI is concerned, and they are very glad that this has come up as a clinical tool to them. Because once they put the implant, it is impossible to do the scan. As of now, the implants are not MRI friendly.
Yes.
Therefore, not very can't do the MRI. So, before the MRI is done, if they have any iota of doubt, they will send the kids to us. And generally, the children to whom this is administered are around age 5 to 6 years of age. And because our Prime Minister has now given 5 lakh rupees as the subsidy to this surgery, and the surgery was costing about 7 lakh rupees for intracochlear transplant or implant. So some of the cases happened that the people from the villages were actually selling out the land and coming to do the surgery, get the surgery done, and they were not getting successful. So at least now, two things are happening. One, once they are known that this surgery will be successful, then they can put in the money. And also the patients who are getting subsidy is 100% successful. In the cases where the patient, we tell them that it will be successful, the patient does not have to spend that time and money. And that subsidy also does not go to waste. So I think these factors have been very useful. And some other disease conditions also. So now, as I mentioned to you, because this data is available to us, but our person who is currently the additional professor, he is not so efficient with the data mining or AI. So we are not collaborating with IIT Kanpur to make more sense out of this data that we are getting from SMR.
Thank you, Alok. Thank you very much.
Thank you.
I'm very happy that you could take time out of your busy schedule. It would have been great that had you been here out here in this auditorium yourself, and you would have enjoyed. But still, you could find time and squeeze time out of your busy schedule. So, Professor Alok Dhawan has got a Midas touch. Whatever he touches turns into gold. With these words, thank you very much. Thank you very much.
Thank you.